All right, hello everyone that is tuning in. This week we're going to be talking about ionic bonding and ionic compounds. This is chapter 15, and I will start by saying that ionic bonding and subsequently ionic compounds are going to be extremely important for you guys to know, especially because they will be built on. This is one of those concepts that just we keep building on it as the semester and the year goes on. And every year I have students at the very end of the year still asking me what an ionic compound is, and I'm like, oh my goodness. So make sure you pay attention here. It's going to make your life a lot easier. It's nothing to, there's some things we go over that I get are somewhat more complex, but this really isn't bad if you just pay attention. So make sure you bear with me here. So when we're talking about ionic bonding and ionic compounds, the first thing you need to see is this word ion. Okay? Ion. Okay? What is an ion? That's what everyone watching should be asking themselves. Some of you might already know, some of you might not, so let me just go ahead and tell you. An ion is when an element, so any element on the periodic table, let's choose sodium. So sodium is a normal element. We call that an element, right? Or an atom. An ion is when it becomes something with a charge. Okay, and sodium specifically goes to a positive one charge. Now, why it does that is exactly what we're going to be talking about in the next couple slides. I'll show you one other example. Fluorine, and maybe some of you out there can start to see a pattern if you look at the periodic table, and you should have your periodic tables out for reference. Fluorine will actually become a -1 charge. Okay? But like I said, ionic bonding, so ions are the key of this. So then we're going to be talking about how ions bond. And so that's going to be a key component of this as well. So let's continue. So the first thing we need to look at when we're talking about anything to do with ions is the valence electrons. Whoops, kind of a bad highlighting job. But valence electrons, as we've talked about before, they're the electrons in the highest occupied energy level. Or if I draw a little atom here, okay, this could be anything. Let's just say this is the nucleus. And you guys hopefully remember the highest, what we're talking about when we say highest is going to be this outermost. So I'll put that up here, outermost. That's going to be the outermost occupied energy level. That's how many electrons are in the outermost or highest occupied energy level. Okay, so there can be electrons floating around in here, right? And we want to know how many there are. That's the valence electrons. This is always the sum of the S and P. If you go back to electron configurations, you remember that the highest energy level is going to contain S and P electrons only for the valence. So really, really simple. Before we go any further, we just need to make sure everyone knows that group 1, its highest level is going to be is only going to contain 1 valence electron. Okay? Group 2, so that would be like something like sodium, right? Group 2 has 2 valence electrons, and that's something like beryllium, first one in group 2. And then group 3 is something like boron. You go all the way past the transition metals, and that's going to have 3. And what you should see here is you have a pattern, 1, 2, 3, going with 1, 2, and 3. Okay, so pretty simple. As you progress the group number, skipping over transition metals, you have 1, 2, 3, 4, 5, 6, 7, 8. So remember, if I'll draw the periodic table kind of poorly here, but just so you guys can see. Okay. And then, okay, so this is kind of what your periodic table looks like, and you have all these 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. We'll add 1 over here, and then you also have like your helium up here and your hydrogen up here. Okay, well anyway, remember, so we skip all this when we're looking at groups. So we have 1, 2, 3, 4, 5, 6, 7, and 8. And the reason I'm drawing this horrible picture is because in the next slide I want to show you, well, first of all, now you know the valence electrons, the number of valence electrons corresponds to the group number. Hopefully you guys can all see that, right? 1, 2, 3, 1, 2, 3. But now is this octet rule. Okay, and the octet rule is just like I showed you. There's 8 groups that we really are focused on. We'll talk about transition metals later, but the octet rule is saying that in the outermost S and P levels, we can only have 8 electrons. That's when S and P are combined. So you remember it's 2 plus 6. And the other thing you really need to know about the octet rule is it is extremely stable. So next we're going to talk about these things called cations. So anytime something forms an ion, again there we see that ion again. Anytime you see something forming an ion, it's because it's trying to achieve the octet rule. Okay? And so with cations, they are going to be losing between 1 and 3 electrons. And I'll show you more about that in 1 second. But metallic atoms, well, we already said it, lose electrons to obey the octet rule, and then they gain a positive charge. So that might be easy enough said, but a lot of you might be scratching your head because, wait, if something's losing electrons, how is it becoming positive? So you see this connection, lose and positive, doesn't that kind of make sense? Doesn't that not make sense? It's kind of opposite of what you would think. And that's exactly what it is. And a lot of students forget this and mess up this because they forget it is opposite. So let's take something like one of these metals we're talking about that's going to form a cation, like sodium. We've already brought it up. So sodium is in the first group, so that means it has 1 valence electron. 1 electron in its outermost shell. So that 1 electron is actually keeping it from the octet rule. Okay, so if you look at it, it has just 1 extra electron that it wants to get rid of. So what it does is it's actually going to ditch that electron, and that electron's going to fly somewhere else, and that's going to actually be a major component in ionic bonding. It's going to become sodium 1 minus. So it lost an electron. Sorry, I said that wrong. It's going to gain a positive charge. So in losing an electron, it becomes positive. But this makes sense because if we look at the electron itself, it has a negative charge. And just like in math, if you lose a negative, you are going to become more positive. So that is something you really need to remember, and that's going to be for all cations. And the last thing I'll leave you with on this slide is when we look at cations, the easiest way to remember is cation is going to be anything that becomes a positive charge by losing electrons. You can remember that, or at least how I remember it, is I draw the T in cation like a positive charge, or just like a positive sign, or a plus sign. Okay, so that positive sign there is going to let you know that. All right, we'll continue with the rest later on. Thanks for listening.